Cool. Hey everyone. So CS253. This week it's going to be a bunch of stuff on. Actually, so today is going to be the end of client-side stuff, and then on Thursday we're going to start server-side stuff. So it's sort of this lecture is going to be sort of a catch-all for all this stuff that didn't fit into any of the other lectures on different client-side stuff. Cool. So before we start, I want to start with a group activity. So if you have a laptop, get it out. And iPads are okay, but a laptop's better if you have a laptop. Some people are eyeing me suspiciously. Why is that? Okay, so what we're going to do is take out your laptop, open up a browser that you don't normally use. So a browser that doesn't have any unsaved work in it. A browser that you're willing to force quit. Okay, so does everyone have an alternate browser open? Okay. So before we go on, how many people here have heard of the annoying site? Okay, great. No one. That's amazing. Okay, perfect. So what you're going to do now is type in theannoyingsite.com, and then do not press any other buttons after you do that. Okay? Do not press anything else. Don't alt-tab anything. Just type in, hit enter, and then wait. Okay. Has everybody done this? Okay. Now, everybody on the count of 3, hold down your space bar. Okay, 1, 2, 3. Okay. Great. So what we're gonna do now is, with a partner, list some of the things that you see happening to your browser right now, and talk about like what are some of the surprising things that the site has been able to do to your computer. So just maybe partner up and just talk about what is surprising about this website.
It's trying to print something. It's trying to download something. It's trying to open more than 100 pop-up windows. According to Firefox. Oh, that's his ASCII art. That's it. Full screen. Really trying to open something. I tried downloading some stuff. Did it successfully download? Yeah, well, some, and then I guess Chrome was like a lot of stuff. Oh, now it's trying to print things.
Okay, so actually, I'll give you guys another minute. All right, let's see. So if you don't know, the shortcut to force quit on a Mac is Command Option Escape, and then you can select the browser and just kill it. That's probably the easiest way to end it. Windows is Control Delete. I don't know what it is on Linux. Yeah. Hopefully it comes back after you quit your browser. Did it come back? Okay. All right, so does anybody want to volunteer? Like, what are some of the things that you saw happen, or like maybe the most surprising thing that you saw happen? It was printing.
Or it was trying to print something.
Oh, to your printer? Yeah. Okay. Yeah, the print dialog came up. Like, do you want to print this page? Anything else? Yeah.
Open full screen.
Yeah, it opened full screen. Okay.
I got a bunch of downloads.
Is your downloads folder full of files now?
Yeah.
Yeah. Okay. Cool. Anything else? Yeah.
I feel like the browser I opened up was literally me opening up the browser for my first time, so I was lucky because
Uh-huh.
And like that's why I could like somehow protect myself.
Yeah, so there were certain things the site was trying to do that that it wasn't allowed to do without permission. Yeah, that's true. Anything else? Yeah, so this is a site which I made a couple, I think a year or two ago at this point, which was motivated by the question of like what's the most annoying website you could put together, and so this is the result. But I want to use it as a way to sort of discuss this idea of UI denial of service attacks. So this is a kind of attack where you can do it in sort of three different goals. Typically, you're overriding the browser's default behavior in some way to make it hard for the user to escape from the sort of trap that you've laid for them. In this case here, I don't know how many people tried to close the browser window, but when you try to close it, what happened? Yeah.
So I tried closing it, and I think it had opened another browser window. So I was wondering where the music was coming from. And it's like the small browser that it had opened.
Yeah, so it tried really hard to get you to not be able to leave. If you actually managed to try the keyboard shortcut to leave, it also prevented that from working. And so that's sort of an unexpected thing where you always expect Command W or Control W to always close the browser window, but that's overridable. And so yeah, that's very unexpected. And then you can imagine this being used, this type of thing being used to create scareware for users. So this is be a site where you land on it and it tells you that your computer is infected with a virus, or it tries to get you to buy some product that doesn't do anything. And it makes it more convincing by sort of locking you on the site and preventing you from leaving. And this can be very convincing for non-technical users. And so that's called scareware. And then lastly, there's sort of like an annoyance factor. Like it's been a kind of recurring thing over like the years of the web. There's sort of troll sites you can send people to that will just do things to their computer and sort of scare them, but don't actually do anything harmful, which is what this site was. But yeah, so this is sort of the idea behind UI denial of service attacks. So one thing that's useful when thinking about these kinds of things is to sort of put the different APIs that the browser gives you into different levels. And so there are certain APIs that you can just use right away without any restrictions. And that would be stuff like anything in the DOM. So if you want to create a new DOM node, you want to apparently you can move windows around without the user doing any, interacting. You can trigger file downloads. You can hide the mouse cursor. So these are all things you can just sort of do immediately when a user arrives on your site. Then there's sort of a step up. These are sort of APIs that the browsers have decided, like, we don't want a site to be able to just do this as soon as you land on it. And so we call those level 1. And with these APIs, the user just has to sort of interact with the site in some way first. And it can be as simple as hitting a key, which is what you saw when you press the space bar. And it could also be a user click. But certain user interactions don't count as like full interactions. So if you scroll a site, that's not going to let you use any of these APIs. That's sort of too sort of fundamental of a thing. It's not expressing user intent. Like the user does not intentionally sort of interact with the site. At least that's the idea. But things like clicks, key presses, stuff like that, those are user interactions. And then there's let's skip level 2 for a second. And then level 3 is sort of you might be more familiar with these types of APIs. These are ones where you're trying to the site's trying to do something sort of very invasive, and so it's going to trigger a permission prompt. Like the site wants to use your location or your camera or your microphone. And then there's this sort of in-between level that is sort of a newer category. And these are APIs where the browser sort of decides whether to allow them or not based on how engaged you are with the site. And this is sort of a compromise between a straight-up permission prompt and sort of just letting sites do stuff right away. And so an example of that is like auto-playing sound. So if you come to a site, a site no longer can just start playing audio right away. This is a change that was made about a year ago. Browsers decided it's just too annoying. You click a link and sound starts coming out of your speakers. And so they decided to gate that behind a user interaction. And that kind of makes sense, right? If you click play on a video, it should be able to play sound at that point. You've sort of interacted with it. It should be able to react with sound if it wants. But then if you want to sort of be able to sort of skip that step and just sort of autoplay right when you land on a site, if you engage with that site all of the time and you are always playing video and audio on it, then the site is allowed because of some sort of vague engagement metric that the browser's keeping track of. And so that's like oftentimes if you go to YouTube, you'll notice it just plays right away, probably because every time you've gone to YouTube before, you've ended up triggering audio and sort of staying on the site for a while, and the browser's decided that like you must like audio on this site, and so it lets it autoplay. Yeah, any questions about these?
For interaction and whatever said makes sense for engagement, is this like a flag is set when the user clicks, or is this like you have to execute something in the event handler? Like if you need a click before you can full screen, does it have to be actually like in the event handler? Or
Yeah, it has to be directly in response. Yeah. So so in general, these things only work if you literally call this function in response to a click, like in the event handler. So like in the function that gets called when the user clicks. Like it has to be sort of directly in response. Yeah, that's right. Yeah, any other questions? Yeah, so it's trying to strike a balance between sort of like not letting sites sort of get permission to use things that that the user would want to be informed of first, but also to not make it so onerous that we're sort of asking for all kinds of permission to do different things. Over time, I noticed lots of things shifting from this level 0 to level 1. I would say like right now the most surprising thing that's still in level 0 is the fact that you can download files. You can literally, a user can land on your site, you don't interact with it at all, and it puts a file in your downloads folder. I think that's kind of surprising. I feel like that should be behind a click, personally, but it does sort of try to limit multiple file downloads. So a site can't sort of put 5 files in your downloads folder. After the first one, it triggers a prompt saying, like, this site wants to download multiple files. It's useful to think about things like this. But this is sort of like as old as browsers. Like this is sort of a classic thing that people used to do. If a site did this, then literally the only way to get out was to force quit your entire browser. Because there was a time when browsers were implemented with a single process, and the entire browser was effectively I don't know if this is literally true, but it was sort of effectively in a single thread. And so the JavaScript that the site is running was sort of, if you go into this loop, you sort of never leave it, and so the browser never gets an opportunity to respond to the user clicking X on the window, or clicking X on a tab to close the tab. So a site could sort of like end your browsing session by just doing this. It was pretty bad. And then sometimes there were some funnier ones where people would make like a list of messages and sort of show you like tell you a story like about how they trapped you on their site and how you're like never going to escape. And so every time you click OK on these little alert windows, you get like a different message and you just can't leave. There were some elaborate ones that just went on for like really long. But browsers introduced some defenses against this sort of really basic level of trolling by offering a little checkbox on these alerts that said, like, after this alert, don't show me anymore. And if you check that, then effectively future calls to alert were no ops. And that sort of solved this problem. But now we actually have an even better solution. If you try to do this in a browser, you'll notice that here, actually, we can just do it. You'll notice what happens is, here we go. Yeah, so if I run this, what's going on here now is there's not even a box for me to bail out of this. It's just sort of, it's almost like back to the old behavior, where it just keeps you here. But the difference is Chrome and all modern browsers are multi-process. And so I've sort of locked up my own site, but the browser itself is running in another process. And so if I click on the X here, it can handle that without being blocked. So it handles that, and then it goes and kills the process for the tab that was in the while true loop. So that's nice. But yeah, so this is actually kind of sad. This was really recent news. So a 13-year-old girl in Japan wrote this exact thing, like with the while loop, and then posted it to a forum. And then the police showed up at her house and arrested her for it, for writing a while loop with an alert inside. There was like a sort of huge internet outcry after this, where people created a repo and said, like, fork this, and we can all sort of protest together. We'll all get arrested for making malware. I don't know. I think it was just a little bit of overzealous cybersecurity law there. But crazy. Okay, so let's talk about some of the things that the annoying site was doing. So I mentioned this API before on the first day of class. So sites are allowed to open new windows using this API, and this is what comes up when you call that. So it's just a little window. And one thing you'll notice right away is the URL bar here is sort of mandatory. And so in this case, I sort of pointed it to an empty page, and the way the browser shows that is about blank, which is sort of a special URL for like an empty page. But this is sort of how we call the API. We can specify the width and height of the window that we want. This might look a little weird, like why are we using a string to specify some options? You'd think maybe this should be an object we could pass in. But this API is so old, I don't know if it's because it literally predates the idea of an object in JavaScript, but it is like one of the first things that probably that Brendan and Ike made in the first 10 days of JavaScript. So it's just a ridiculous API where you have to literally do key values with commas and stuff, and it parses it out. I don't know why. And these first two parameters are also, they don't do anything anymore, so you just pass in empty strings. We'll actually talk about what they do in a second. But yeah, and then we can move the window around. And so opening up a pop-up window is something that users don't like. And so the sort of middle ground that browsers came up with was, well, we can do that in response to user interactions. So this is window.open is a level 1 API. So it requires the user to do something, and then you can open a window in response. And so that's what we're going to do here. We just add a click listener, and then we open a window up. So that's what the site did when you held space. It did something like this. Now, to be extra annoying, you want to move the window around in an interval. So it sort of moves on its own. So that's the code for that. And then sort of turn it up a notch. We can sort of intercept every possible event that the user might do to interact with the site and to open a window in response to that. Yeah, so this is a little function you can write for that. And so this is why when you were sort of scrambling around trying to close the site, any button you pushed sort of just made it worse. Also, if you sort of missed hitting the X on the window and you clicked sort of on the page, that would just cause another window to open up. Yeah. OK, so this is sort of the complete function for sort of opening a window in response to sort of any possible user event. The details aren't too important, but we basically put it in a random location. And then there's a chance that it's actually blocked by the pop-up blocker, and then we want to detect that. And then what we're doing here is we're actually putting the entire, we're putting all the windows that we've opened into an array, so that we can, later on, every time you click, we can sort of bring them all to the front by focusing them to make it sort of more annoying. But yeah, so here we go. This is exactly what it is. So basically, if you click on anywhere on the site, we call this function, and then we sort of bring all of the windows to the foreground. Yeah, I don't know. I think this stuff's pretty funny. Yeah, and then this is the other thing we add in. So we want to make the windows kind of bounce off the edges of the screen. And so there's a little code to do that. Again, the details aren't important. Yeah, so let's keep going. And then, of course, we're allowed to play video. I mentioned, though, that we can't play video with sound unless the user has clicked. And so I think in the current version of the site now, that actually mutes the video player by default. But yeah, so we just pick a sort of random video to play. And then this is the thing I mentioned about how we were preventing the windows from closing. So when a site wants to register that it's interested in handling particular keyboard events, it can do that by sort of saying, when a key is pressed, call this function. But the browser doesn't want people to be able to say that they want to listen to Command W being pressed, as an example. On a Mac, Command W closes a tab window. And so they don't want a site to be able to override that. That's sort of too fundamental of a behavior. And so if I go back, you'll see here, where was it? There's these two functions here. When a user does a click or a tap, there's this event object that your function is given. And you can call prevent default on it, which sort of says whatever the browser was normally going to do in response to this, like don't do that thing, because I'm going to do something different. But in the case of Command W, you can't prevent that. It's sort of it's too abusable. But the way we worked around that here was basically when a user is going to push Command W, they first have to push Command, right? OK, so when they push Command, if we do something to sort of interrupt the W that's going to follow, then we can make the browser sort of treat those as two separate events. So when they push Command, we call show modal here, which will 50% of the time show an alert with a cat in it, and 50% of the time will show you a prompt to print the page that you're on. And so when that comes up, the W that you press to follow it is sort of intercepted by this like print page, and it doesn't actually close the window. Yeah, a side effect, though, is in Chrome, I think it actually freezes the window and makes it easier to click on the X. So trade-offs, but yeah. So this is sort of another thing where it's like, this is definitely not intentional behavior, but it's just hard to think of all these cases, and so this is the thing that you can do. Yeah, okay, let's keep going. Here's just another thing you can do, just like throw up an alert every 30 seconds, just for more confusion. This is an API that lets you specify that when your page is about to be closed, you would like this function to run. And in particular, if this function sets event.return value equal to true, or to a string or anything that's truthy, then the browser will bring up a prompt that's like, are you sure you want to leave this page? And this is sometimes useful if you're on a page where changes haven't been saved or haven't been sent to the server yet. You might have seen this like in Gmail. If you send an email, but like your internet's down or it's still sending, and you try to close the tab really fast, it'll say like, hang on, like we're not done. Sort of, there's pending actions. So Gmail can sort of throw up an alert and let you know that if you actually close the tab, your email might not get sent. So this is useful. It used to be that you could actually set a string here and explain to the user why you don't want them to leave your site. Like sort of tell them like, you know, the reason why, what will happen if they leave. But that ended up being abused too much by sites that were trying to scare users to keep them on the page. So they could put up things like, you know, if you leave, like you're going to get a virus or something. Or in the case of earlier browsers used to sort of be really unclear with the buttons that they showed you. So they would show like, do you want to leave, like OK or cancel? And then the site could sort of put a string in there that would tell you like, to stay on the site, push the opposite of what you should actually push, and then to leave, you know, and so their wording would confuse you when you click the wrong one and you just stay on the site, and then you just get trapped, basically really confused. So anyway, now no matter what you put in here, if it's truthy, the browser will sort of just show its own message that says, like basically, would you like to stay or leave? And it makes the buttons really clear. But anyway, this is just an annoying thing you can throw in. This one is great. Basically, what this says is, whenever the user hits the back button, call this function and go forward. And so the back button stops working. Yeah. And then you might think, well, maybe they'll click and hold on the back button, and that brings up a list of a bunch of entries, and maybe they can sort of skip past, like you go like three pages back and sort of skip past this function running. And we can sort of think of a defense against that. Well, we can just push items into the history. And we can push enough items in that it sort of pushes it off the end. And so when they hold down, all the entries that they see will just be the annoying site and not anything before. So yeah. Again, like all these APIs have valid use cases. Like this one in particular is really useful if you're building what's called a single page app. Pretty much any app you build with React these days uses this internally. And the idea here is, with this API, is you can set you can sort of set the URL that the user sees in their browser to whatever you want, as long as it's on your same site. And this way, when the user clicks around, rather than allowing that request to sort of refresh the whole page, like cause an entirely new HTTP request to go to the server, and then the HTML comes back, and we treat that as a fresh page, we can instead just intercept the click with JavaScript and then do something ourselves, maybe hit an API or something, and then update the DOM without causing the whole page to reload. And when we do that, we may want to update the URL to sort of act as if they really went to a new page when they really didn't, if that makes sense. So this API is really, really handy. It's used all the time. But yeah, it can also be abused. And then this is another one. This is really useful. For a long time, people had to use Flash to do this, to copy text to the user's clipboard. But now you can do it directly with an HTML5 function. But yeah, this is an API that you can just use in response to a user click. So basically, you can just say, if the user ever interacts with my site, if they click anywhere at any point in time, or they hit a space bar, or they try to go Command W, whatever they do, I'm going to just stick this on their clipboard, this cat. Also with a link to the site. So if they accidentally paste, then they're sort of making it go viral. But yeah, so this is another annoying one. You can't, fortunately, you can't cause the user to paste without a permission prompt. And can anyone think why that's really important? Why would we not want to allow a site to cause the user to paste? Yeah.
Just copy your password.
Yeah, exactly. So you don't want to just because you're on a site and you click on a button, like it shouldn't be able to just sort of steal whatever's on your clipboard. Yeah. So that one causes a prompt to come up. But copying to your clipboard, it's like that one's okay. You know, it's just trade-offs. And in the case of this, in this case, it's like we want. I'm going to talk a little bit about it later, but there's sort of this trade-off always between power and security. It's like, do we want web apps to be able to do this stuff, or do we want to sort of be really paranoid and not allow them speaking of power that we want to give to web apps can actually ask to register themselves to be handlers for certain protocols on your computer. So you could say, like, a site could say, I want to be sort of the handler for any time you click on a Bitcoin link, go to this site. And then maybe you have a web wallet or something there, and so you can sort of register that you want to sort of handle these protocols. So this would be literally if you go to, like, mail to : and then an email address, you could the site could sort of ask to handle that. This does bring up a permission prompt, so this is not likely to sort of do much damage, but we might as well ask in case they accidentally allow it. That's the idea anyway. OK. Same thing with camera and mic. Of course, this is not going to be allowed unless the user clicks allow. But if they do accidentally click allow, this is a fun one. We can actually turn their flash on their phone or device and blink it. It's called torch, I think. Yeah, where is it? Yeah, torch true. That turns on the flash. Yeah. And so this one's interesting. This one, you used to be able to cause devices to vibrate without any interaction at all. So this quickly got sort of changed into a level 1 API instead of level 0 because ads were just causing, like, vibrations every second to attract attention to the ads, obviously. So yeah, this is one of those ones where it was too abused. This one's really useful. This is a picture-in-picture, so this lets you take a video and sort of pop it out of the page and have it float, like, in the corner of the screen so you can multitask and do other stuff and continue to watch the video. There's an API for this, so literally if the user clicks, you can just sort of pop a video out and put it in the corner. And yeah, that's the code to do it. This one, so someone mentioned that their cursor was hidden. This is really simple to do. You just, you can literally, it's a CSS property, cursor, and you can sort of set the cursor to whatever you want. There's some really interesting attacks that involve messing with the user's cursor. In this case, we just made it go away so that they'd be sort of more disoriented and sort of, it would be harder for them to figure out how to close the windows. But there are some interesting attacks with cursors where you can literally put a fake cursor on the page that's sort of offset from the user's true cursor, and you hide the true cursor. And then, so the user thinks their cursor is over here. And all browsers had a bug where even if you sort of take your cursor off the edge of the page, sort of out of the browser window, and you're now, like, hovering over other applications on your computer, the custom cursor was still remained. And this custom cursor, remember, it's offset from where the real one is. So they could offset it just enough so that when you go to interact with something on the page, the true cursor would actually be clicking allow on a permission prompt. So you'd be just accidentally, like, turning on your camera, basically, or something like that. That one was fixed, but yeah, that was pretty bad. And then, so triggering file downloads. This one is really easy. Also, you just make a link, and then you set the destination to whatever the file is that you want to download. And then if you set this download attribute to some name, then that will be what the file is named when you click the link. And can anyone think, like, maybe there's one reason I think why maybe this API is still level 0 and why sites are just allowed to call it. There's, like, a use case that I still see sometimes on the web where, like, this is used. Does anyone else run into it? Yeah.
I'm just thinking, if you ever go to a site and they tell you to go somewhere to download the link, then I expect that when I click the link, it'll, like, maybe take me to some window and it'll immediately start the download.
Right. So if it's taking you to another page, that page should maybe be able to just start a download.
Right.
Yeah.
I expect that to be like a download button.
Yeah, you expect that to, yeah. So that's right. Yeah, basically, there's this sort of common pattern where you'd click a link to go download a file, and it would take you to a page, and that page might have, like, thanks for downloading this program, and then that page wants to cause the download to happen right away without an additional click, if that makes sense. And sometimes I'd see ads on that page too. It'll be like, your file download is starting in 10 seconds, and it would count down, and you'll see, like, an ad until the file downloads. But yeah, so that's the use case I think that they don't want to break because a lot of sites rely on it. But yeah, anyway, that's that. Full screening is also really easy. There's just some backwards or some sort of browser differences because they're all using these prefixes for now. But it's also really easy to do that. OK, this one is interesting. So we all know we can all understand what this is doing now that we've talked about CSRF. So it turns out there's a bunch of sites now. A lot of these are fixed now, but last time I tried, Google's hasn't. Yeah, I read a comment. Oh yeah, so some of them still work. So literally, if you go to this URL here, then you get logged out of your Google account and also your YouTube account. And what's interesting about this is a GET request. And so remember, with GET requests, anyone can cause a GET request to happen by just making an image that points to this URL, right? And so literally, if any site on the internet just makes an image and puts that in as the URL, and you visit their site, the browser will try to load that and treat it as an image, and you'll be logged out of all your Google, all of your Google and YouTube accounts. It's really annoying. And I don't know why they haven't fixed it. I really don't know. The correct thing to do here is this should be a post request, right? And we should be very concerned about the potential of a cross-site request forgery happening. So we want to use same-site cookies so that another site couldn't trigger a post with our cookies attached. But yeah, I don't know why Google also must not be using same-site cookies if this actually works. So I don't know what the story is here. It would be interesting to find out if anyone knows. Yeah.
It looks like LiveJournal and Beacon are post requests.
Some of them are posts. Yeah. These ones I think work by making a form, setting this as the action for the form, and then setting the form to post, and then clicking the submit button, because that is allowed. And so yeah, again, they must not be using same-site cookies if that worked. Yeah. But yeah, so you can just iterate over this and sort of see what works, and that's really bad. Okay, and then this one, so the searches, this one's interesting because, yeah, I tried to sort of come up with family-friendly but embarrassing searches. But what was that?
Why do I feel so empty?
Yeah, I don't know, man. No, but actually, so the idea here is what we're trying to do is cause sort of entries to get added to the browser history for embarrassing searches. That's the idea of this attack. And if we were to try to put, like in this case, this Bing search page into an iframe, they are indicating with that HTTP header that we talked about, remember X frame options, they're indicating that they don't want to be framed. So that doesn't actually work. But even if they weren't doing that, there's another problem, which is that if you load a site in an iframe, that doesn't get added to your browser history because you didn't navigate there directly. Like think about it, like every ad you see that's in a frame doesn't get added to your browser history, right? So this isn't going to work. So what we want to do instead is actually pop up sort of a pop-up window and set its destination to be the search. And that is treated as a sort of top-level navigation, as if you visited it yourself. And so that will cause that to get added to your search history. Now yeah.
So the same origin policy would prevent a script from like accessing data from a different origin, but you could just navigate the user there, and that's fine.
Yeah, you can navigate the user directly there. Now, if you remember with same-site cookies, do you remember there was those two options on same-site? There was lax and strict. So if a site says that they want strict same-site cookies, then when you go to open up a window to them, the fact that you opened up that window, like the attacker opened up that window, will cause the cookies to not even get sent if you're in strict mode. But in lax mode, they will get sent. Anyway, but we don't even care about that here. We're just literally just trying to get them to visit it so it gets added to the browser history. Yeah, and then the other side effect of us doing this is we actually can't move this window around anymore because now it's on another origin. So we're not allowed to call move on it and move it around the page. Move it around the user's screen. But remember, we can navigate frames. Do you remember that? So if you have a reference to a frame, you can navigate it to a different location. And so because we opened this window and we have a reference to it, we can actually at any point in time sort of make it point to a different destination. And so if you notice what was going on in the annoying site was it would navigate the user to an embarrassing search, and then like a second later, it would navigate them back to an annoying video, and that would be on our own origin. And at that point, we can move the window around again for like another second or two, and then we navigate them to Bing again for a different search. And then every time it's on Bing, it's frozen because we can't sort of move it anymore. Anyway, it's just interesting when all these sort of same origin things we talked about, you can actually understand exactly how this works by thinking through all that stuff. But yeah, okay, so this is the last one I think I'm going to mention. There's actually more things in here, but I don't want to just make the whole lecture about this. But this one is really interesting. So this is called tab nabbing. So tab nabbing is an attack where when a site links to let's see. So let's do a concrete example. So a harmless site links to a malicious site. So say you send a link to your friend on a chat service, and the user clicks that link, right? That chat service probably doesn't want you to leave their chat page. So what they'll do is they'll do target equals _ blank. Does anyone remember what this does? It makes a new tab. Yeah, it's a really weird API, but that's the way that you can say, I want this link when the user clicks it to open in a new tab. Okay, so like a lot of sites that don't want you to sort of leave them will do this on all their links, just because then you'll still have their thing open in the tab still. In fact, also it's also market dependent. I think in China, a lot of sites just sort of do this for every link, even internal links, and so people just end up with tons of tabs. It's sort of just a cultural difference. But yeah, no. Normally on like Western sites, the target blank is only reserved for external links in the cases where a site really just doesn't want you to leave their page. But most of their own internal links would not have this, right? Anyway, but the point is that that in this situation, so the users clicked this link, and now they have a new tab open on example.com in addition to the chat site that they got this link from, right? Like, let's take Facebook Messenger as an example. They have Facebook Messenger open in a tab. They click the link. Now they have example.com open in another tab, right? Well, it turns out that example.com has access to an API called window.opener. An opener is a reference to the window that opened this window. So in other words, example.com, if it looks at window.opener, that's going to point to like Facebook Messenger window that the link came from. And what do we say? If you have a reference to a window, you can navigate that window, right? So that literally means that if you click a link to this sketchy site, it can literally make your Facebook Messenger tab change into whatever it wants. It could make it change into a fake Facebook Messenger tab that asks you to log in again. And so when you go back to it like 10 minutes later, it's going to say, oh, you've been logged out, and you're just going to type in your password and get owned. So this is really bad. It's called tab nabbing. This is some code for maybe how you would do it. So here's the idea. So basically, we want to, this is a function that just detects if we are on the same, let's see, what's the point of the is parent same origin? Oh yeah, basically, yeah, we only want to navigate, this is how you do it. So window.opener is going to point to the Facebook Messenger page, and we're just going to navigate it to our own site. That's the idea here. But we only want to do that if we know that it's a bad function name. It shouldn't be called is parent same origin. Sorry, it should be called is opener same origin. But anyway, we're only doing it if basically the page that opened us is not our site. If someone else linked to us, then we want to do this. We want to do this attack. But if it's our own internal link, we link to our own page, then we're not going to do the attack. Does that make sense? Okay. Yeah. But yeah, so here's a video of it in action. Somebody made a video. Somebody showed this on Reddit. So they posted this link here, and then they went back to the like sort of main page of the subreddit, and here you're going to see they refresh, and this is the link to this attack site. And when they click the link to load it up, okay, they're just clicking random things right now. Okay, there we go. They click the link to this attack site, and if you notice the top left, you see how Reddit's getting navigated right now? It's loading, and so they're going to they're simulating that they're reading this article, and then when they're done reading, they click X, and then bam, they're not on Reddit.com. Now you might be you might notice that it looks like Reddit.com. We're going to come back to that in a second. But yeah, they're actually not on Reddit.com right now. And this request, that password they typed in just got sent to this attacker's server. And there's the password right there. Yeah. So that's a pretty I don't know, that would fool me, I feel like, right? So yeah, I don't know if this is going to, I think it's just going to show you what I already explained. I don't think we need to see this, but I'll let it go. I think so. It's not actually pointing to Reddit, right? It's like RED. It's there's like a extra accent on the D. Yeah. So yeah, that's bad. So we'll come back to that accent on the D thing in the URL. We'll talk about that. But how do we defend against this? So what we can do as the site that is producing the link to this external page. So if you're Facebook Messenger in this example, you would add rel equals no opener to your link. What this says is I want the link that is opening in this new tab to not have an opener reference. So when that tab does window.opener, it's going to be null instead of actually pointing to our window. Another thing you can do, there's this new HTTP header. I don't even know if it's supported in any browsers yet, but it's a spec that's sort of developing, and hopefully will be available soon. But if you add this header to your page, you can sort of ask the browser, like, hey, I really want to be isolated from other sites. In particular, it will literally use a separate browser process for your whole site, and it will disable window.opener from working, and it will disable post message from working. So nobody can really interact with you. So this is a really powerful header. I don't want to get into this right now because I don't have time, but when we talk about browser architecture, we'll talk about preventing side channel attacks like Spectre and Meltdown, and specifically this header can protect your site from side channel attacks. So it's a really powerful header.
I just want to clarify. So this means that nobody else can make me the opener of them.
This means that nobody can. This means that if your site links to another site, then that site's window.opener will be null. So it doesn't have a pointer back to you, basically.
Right. So they can't just make us the opener.
Yeah, and also it sort of severs all sort of cross-window ties. So if they tried to, let's say that you didn't have the frame, the no framing header, so you were able to be framed. Typically, what would happen is if a site frames you, your site is being loaded in the same operating system process as the outer page, and that's potentially bad for it can create side channel attack vectors. But if you use this header, then in that situation, that iframe will actually be running in a completely separate process, and then also post message breaks as well. So it's like a much higher level of isolation. Yeah, I hope we have more time to go into this later because it is kind of interesting. But yeah, anyway, okay, let's keep going. So I wanted to mention, I think that it's interesting to look for these different annoying features. So if anyone finds any additional things you could add to the annoying site, like I'll give you a couple points of extra credit, because I think, well, one thing is the site isn't very good on mobile right now, because opening windows and moving them around doesn't really work on mobile. But if anyone can think of sort of other browser APIs that could be abused and add them to the site, it's really good. And browser vendors are actually like looking at the site as a sort of measurement of how good they are at defending against this kind of stuff. So there's this one guy on the Chrome team who I keep seeing like his commits, and every time he commits, like a feature breaks on the annoying site. So like, so they're using it as sort of just a measure. It's like almost like a test case of like how bad is our our UI security, basically. So anyway, it is sort of worth getting more annoying things in there because the vendors are looking at it. So anyway, there's an opportunity. But yeah, so I think that this sort of example brings to light this conflict between like what the browser is trying to be. On the one hand, some people think it should be a simple document viewer. Like you'll see a lot of people whenever these APIs are being discussed, they're like, why are we adding more stuff to the browser? I just want to be able to view pages, and I don't want all this bloat in my browser and all these security issues that come from all these fancy APIs. And I sympathize with that. But on the other hand, like I also want the web to be this powerful app platform that can compete with native apps on desktop and native apps on iOS and Android. And so the browser vendors feel that way as well. They want people to use the web, and they want people to make websites. And so there's this inherent tension where we really can't have both. We can't really have the best of both worlds a lot of the time. And I think even Pete mentioned this in his fingerprinting talk. We have sort of a real downside where every time we add one of these APIs, we're oftentimes introducing additional fingerprinting vectors. And for a long time, the browser vendors just said, like, look, it's so, like, we're in such a bad state right now. Like, the user can be fingerprinted so easily that whenever somebody would bring up a criticism of one of these APIs and say, wait a minute, like, now we just added, like, another 5 ways that this user can be fingerprinted, they would say, well, look, like, there's already 100 other ways. Like, it doesn't matter. We're not making the problem any worse. And I think that's starting to change a little bit in a lot of the non-Chrome browsers, at least according to Pete. He was telling me that the mindset sort of is shifting, and the idea is like, let's not dig ourselves any deeper into this hole, and maybe we'll be able to sort of undo some of the problems and eventually get to a world where we're not as fingerprintable. But yeah, this is another one of the trade-offs with powerful features. So this is a paper. Actually, Pete wrote this paper, and I love the title. Websites don't need to vibrate, or most websites don't need to vibrate. A cost-benefit approach to improving browser security. And he picked on vibrate because that's like it seems probably like one of the most useless APIs. But what I love about this paper is, it goes into all of the different APIs that are the powerful APIs that have shipped and the ones that are being proposed, and it looks at sort of how useful they are. So the way it determines usefulness is it has basically tries to figure out if we disable this feature, how many sites break, basically, right? And so if a lot of sites break, that means that's probably a very beneficial feature for the user. It's a very rough metric, but it kind of makes sense. And then how do we determine the cost of this feature? Well, we look at how often is this feature implicated in security vulnerabilities in the browser. So if you look at one feature in particular, WebRTC, it enables peer-to-peer video and voice calls. It's a very powerful feature, but it also is a ton of code. It's millions of lines of code, and it's a source of a lot of security issues. And so that would have a very high cost, but also potentially a very high benefit because users can do video and voice calls. That's really great. But yeah, so he tries to sort of figure this out and look at the lines of code, known attacks against each of the features, and then determine like what features should we keep and what should we cut. And so I think it's very interesting. And then, well, yeah, so basically you might think, well, OK, there's an easy solution to this. Just have the site prompt the user for everything they want to do. Then we can have the best of both worlds. Like by default, the browser is a document viewer. And then every time a site wants to do something powerful, it just asks, right? Then the user's protected, right? We could do that, but there's this paper from 2010 that did a pretty large study with Chrome and Firefox users at looking at the effectiveness of security prompts that the user gets shown. And there's this thing called, I think it's called like, what's the term? Something fatigue. I'm forgetting it now. Like security prompt fatigue, something like that. I forget the exact term. It's in the paper. But basically, there was work before this that showed that most browser security prompts were just coming up way too often and were way too unactionable for the user. The user couldn't figure out what was being asked, and so they just sort of would hammer at the dialogue until it went away and let them get on with their life. And so a lot of people sort of started to believe that showing too many prompts is a problem. We can't just be asking the user every time we want to do something. We should probably just be trying to do the right thing more often for them by default. And that's very true. But this paper pushed back a little bit on that idea and sort of tried to argue that actually browser security prompts in Chrome and Firefox are quite effective at keeping people safe in certain situations. So I'm going to mention a few of them, but OK, I guess I already answered this question. Basically, you might think that these warnings are ineffective, but it turns out that users click through fewer than a quarter of the malware and phishing warnings in Chrome and a third of Firefox SSL warnings. So that's a bunch of users who aren't going to this sort of potentially dangerous site that the browser is warning them about. And then in particular, the Chrome SSL warnings used to be really bad, and 70% of users would click through those, which is a very high number. And so the conclusion of the paper was sort of that actually the design in these prompts matters a lot, and we shouldn't be so sort of hopeless about it. If we're very careful about how we word them, we can have some sort of tasteful prompts in certain places that users can understand, and we can protect users. But we still want to be worried about potentially showing them too many all the time. So yeah, and then this is an interesting question. What do you guys think? Do you think advanced users click through phishing warnings at higher or lower rates than average users? Yeah? Higher rates?
Higher.
Why?
Because you think you know what you're doing.
Think you know what you're doing? Yeah, that turns out to be right. Yeah, so Linux users and other early adopter users. So early adopters, they determine that based on if you're using a beta version of the browser or a nightly version of the browser, then you're an early adopter. Yeah, they click through malware and phishing warnings at a much higher rate. Yeah, you're right. Yeah, but anyway, I think the point is basically just that this tension isn't going away. We can't solve it with more prompts, although prompts have their uses. So it's sort of just an inherent problem in this design space. But I think if anyone has ideas for how to make this stuff better, this is really important work, I think. OK, so what I want to do now is go on to phishing. So we've sort of finished the UI security, and now we're going to talk about phishing. So before we go on, any questions about UI security? Denial of service. OK. OK. So, oh yeah.
Wait, does that tab nabbing attack still work in modern browsers?
Yeah. Yeah. Yeah, that still works. There's this interesting repo. If you want to read some interesting stuff, you can search interventions. I think it's search browser interventions. There's a repo where browser vendors discuss potentially intentionally violating the spec and doing things which protect users, even though it's going to break backwards compatibility with the web. And that's generally a thing they don't ever want to do. But then this is a repo where they can sort of like argue about whether it would actually be more good than bad to actually violate the spec and break sites. And one of the things that they are talking about is turning that off by default, because it's so unexpected, and because the way you have to defend against it is so hard. You literally have to make sure every link on your site says rel equals, no opener. And I mean, it's not that hard to add if you're using like some kind of a framework. You can just have like a sort of component that makes links and just stick that in that link component, and then every link on your site will get it. But yeah, so they may change the default, but right now it still works. And in fact, it actually used to work on Facebook Messenger. That's like how I discovered this thing. Was I noticed it on Facebook Messenger, but they fixed it since then. But yeah, it used to be on a lot of sites like that. Okay, so phishing. So phishing is just acting like a reputable entity to trick the user into divulging sensitive information like their username and password. And the idea here is it's just often easier to just trick a user than to try and actually attack a system head-on and find a vulnerability. So there's this quote from Bruce Schneier, a security dude, who says, like, security solutions have a technological component, but security is fundamentally a people problem. And so that's sort of the core idea of phishing. Is like, let's attack the people, not the actual crypto or the implementation or the website itself. There's also this really nice Saturday morning breakfast cereal comic about it. Yeah, so oftentimes the real attacks are just as easy as calling somebody up and talking to them. Yeah, so let's talk about this URL issue that we mentioned before. So does anything look weird about this URL? Can you detect anything in the UI at all that would indicate that this is not actually apple.com? What was that? Oh, hey there, yeah. Yes, that seems like something maybe they wouldn't say, but besides that. No, I mean, it's basically, I can't tell a difference. So what's going on here? Let's actually just see it in action and see that it actually works. So if you look here, this is like the site, the same site that from that screenshot. So it looks like we're on apple.com, but we're getting a completely different page. Yeah, this is really bad. If I copy it though and I put it into a different browser like Chrome, we get a different behavior. So notice that. That's interesting. So it's rendering the URL completely differently. Let's try actually pasting in the URL from my clipboard and hit enter. It changes it into that. No matter though that it actually looked like that when I pasted it in. Like, that's kind of interesting. And then let's try Safari just to see. Oh no. No. I've done that to myself so many times. Okay. All right. Oh wait, no. See, now my clipboard is replaced with. All right. Okay. All right. Oh no. Okay, hold on. I'll get it from somewhere else. I'll get it from Firefox. Okay. Okay. All right. Okay. There we go. Okay. So yeah, Safari also does the same thing. So what's going on here? So what's going on is that. Oh yeah, actually here's one more thing to show you. If we go to a text editor and we paste in the two URLs, I've already done that here. So the top URL is the fake one, and the bottom one is the real apple.com URL. So they look exactly the same. But if I take this file now and I open it in a hex editor, so a hex editor is just like a tool to look at the bytes, the individual bytes that are in this file, and not render them as letters, but to actually look at the true value. We see here that basically up until the // I think, so if you see when I highlight this text here, it's also highlighting the text on the right. So when I highlight this, you'll see that that's sort of the up to the dot, the bytes are exactly the same, but then starting at the A in Apple, they diverge. So what's going on is that this is Unicode right here. So these are letters in Unicode that look the same, but are actually different byte representations under the hood. So the Unicode standard actually supports. Oh yeah, before this, let me finish what I'm saying. Yeah, so basically the Unicode standard supports sort of different languages, right? We want to be able to represent letters from all kinds of different languages in one unified standard. So the thing you'll often see is UTF-8. That's the name of the Unicode standard. And it has like letters for every language. But in particular, there's certain languages which have letters which are the same as the Latin letters that we use in English, but for whatever reason, and I don't know the reason, but instead of reusing those Latin letters that we already have in the ASCII set, they decided to sort of duplicate them over there in the space for that language. So in other words, there's literally two letters that look visually indistinguishable, but are literally actually treated as different letters by the computer. So that creates this issue. So if you have a host name with a Unicode character in it, one thing you can do to make it like obvious what's going on is you can sort of translate it into this thing called punycode. And that's what Chrome is doing and Safari is doing. And that's why we're seeing this weird xn -- thing. So what Chrome is saying is, we think that this is a confusing URL. And so what we're going to do is, instead of, like in this case, this is the German for Munich. This gets translated into this. And what's going on is it sort of strips out the letters which are Unicode, which are not in the standard ASCII set. So that's why the U, I think that's called an umlaut, right? That's why that's gone. And then we have just the remaining letters. And then here, this indicates basically that we're going to insert in that particular Unicode U into this position. So this encodes that somehow. And yeah, and so then and the xn -- prefix. Can anyone guess why we put that in there? So how we tell the difference between this and like potentially a domain that I could register? Like, what if I registered this as a domain? Wouldn't I be allowed to be allowed to go buy this? And then how would I differentiate like this from this, right? So what we do is you can't have 2 dashes in a row in a valid domain that you go and buy online. And so by doing xn -- in front of this, we've sort of indicated that this is actually a punycode domain and not a real domain that somebody could go buy. That's the idea. Anyway, so yeah, and it certainly comes in handy. Well, yeah, I don't think in this situation here, like this is probably not going to phish anybody. So it actually makes less sense to render it like this. And so Chrome will actually, in the latter case here, just show you I think that looks like Japanese to me. It will just show you that character directly. So it sort of only intervenes when it thinks that it's going to be confusing. And there's rules for how it does that. So yeah, so in particular, the Apple versus Apple. Oh, actually, I can kind of see the A is different. Yeah, or am I just imagining it? No, I want to say that looks different. Yeah, that A looks different. So the A is different in that one. And so that when it translates it to punycode, you'll notice that the A got stripped out and then replaced with this thing. And so that's sort of Chrome protecting you. And so the rule that they use is basically if one letter is from a different language. So basically, if you have a domain made up of letters from 2 languages, and the letter that's from the non-English language is a lookalike character to an English letter, then it will render it like this. Does that kind of make sense? Yeah. So what's the attack? Why is Firefox showing us apple.com? Why did Firefox have trouble here? What did they do? So in this case, we just changed the A to this. This is called, I think it's a Cyrillic A. It's yeah, Cyrillic is what the language set that it comes from is called. But what they did in the demo that I actually showed you in Firefox was they just made all the letters come from Cyrillic, and now it's like, oh, it's one language. We'll just show it, right? So that kind of doesn't really work very well. And so the fix that Chrome implemented is for any TLD. This is called a TLD, a top-level domain. Any TLD that is not itself using Unicode letters, then whenever the left side has any lookalike characters in it at all, then it will be rendered like this. So basically, there's certain TLDs. There's certain these right here that are literally other like foreign language characters in the extension. And in that situation, then you can have sort of foreign letters in the front part as well. Anyway, the details aren't too important. The point is that there's some subtlety here, and it even caught all the browsers out. And in 2017, somebody blogged about this, and everybody fixed it, but Firefox still hasn't fixed it for some reason. but yeah, so it's called an IDN homograph attack. And you can kind of think of it like domain squatting. So domain typo squatting is the idea that you register a domain name that is one letter off from a popular company's domain, and you hope that people make typos when they're typing it in. And then you show them a phishing page when they go to that typoed URL. So it's kind of like that. The difference, though, is with typo squatting, the user is actually making a typo on their keyboard, whereas with these attacks, no one's going to accidentally type like a Greek A letter by accident. The way it happens is you get sent a link, or you click a link and you get tricked that way. But it's otherwise very similar. And then I just wanted to point out something kind of interesting is handwriting has this issue too, in some ways, where in particular this word "samt" in Arabic means direction. And when it was being transcribed, like a long time ago, the scribe confused an M with an NI, and so I know Zenith and Samt don't look like they're related, but if you kind of squint at it, it's like Zenith, Summit, and then the NI. If you made this an M, then it would be like Zemith, Semith, like Semith. It's not that off from each other. But anyway, yeah, that was like a sort of transcription error. And certain typefaces even still have this stuff today, where like if you look kind of from far away, you might think this is an M, right, or that's an M, when really it's an RN and an RRI. So yeah, depending on the font that's used. And in particular, for the domain font, the font that all the browsers have chosen to use doesn't distinguish the Cyrillic letters from the English letters, and so it's really effective. Yeah. Another case where this is actually used intentionally is this is a Turkish typewriter, and if you notice, they're missing a number 1. Well, why did they not bother to put a number 1 on here? They were low on keys, but like, what's the sort of workaround? Use the letter L. Yeah, exactly. Use the letter L. That's how you type a 1, because a lowercase l looks the same as a 1, so they didn't add a key for 1. That's literally the solution. And then how do you do a semicolon? Because they don't have a semicolon key either.
Use a colon and then put a comma on top?
Yeah, so in a typewriter you can backspace. You can type a colon backspace and then do a comma over it. That's semicolon. So yeah, it's kind of interesting. And then I think they said exclamation point was like, it was something like, it was like a, how do you do it? It was like a period and then some other, I forget what it was on top. But anyway, you can like hack all the different letters basically out of this limited set. And this is actually the L in 1 thing is still a thing that confuses us with modern browsers as well, because 1s and L's also still look really similar. And so you might be not on Google.com, but on Google 1e.com, and it might look similar. So yeah, so the solution is to use Punycode whenever it could potentially be confusing, and the updated solution since 2017 in Safari and Chrome is to basically just, when the entire domain is made up of lookalike letters and the top level domain is not like an international domain, so it's like a .com or .net or something, then we just always show it as Punycode. And the other thing to mention is if you're using a password manager, then you're protected against this, because your password manager isn't going to be fooled. Your password manager, when you say go fill in the password for the site I'm on, it's going to say, wait a minute, you've never been to this site before, and it's not going to fill in your password. So that's a huge advantage of using password manager for users. It's much harder to get phished. Before we go on, any questions about this IDN stuff?
Sorry, back to the Apple site, how did they get the secure lock thingy?
Oh, yeah. So the secure lock thing just means that you're speaking to their server over a secure connection.
Oh, I see.
Yeah. So it used to be the case that, I don't know, people maybe thought that like the company that you buy this like certificate from would like do some checks before they give you the certificate. They would say like, should we issue this or not? Like, is this a valid request or not? But it turns out like they make money when they sell you the certificate, so they have an incentive to sort of just automate it as much as possible, right? And then just sell it to you no matter what. And nowadays, like we've sort of given up hope on that being like a defense mechanism, because there's even this. I'm sure you maybe have heard of Let's Encrypt, which is a service that just gives you a free TLS certificate, and all you have to do is prove that you are in control of the domain, and they don't even look like there's no human involved at all. Like you push a button, and they send a request to your domain, and if you respond in a way that proves that you are in control, then they just give you a certificate. And so, like all this kind of sketch sites with locks are like way more pervasive since that became a thing. But I think the argument is like, well, it's still better that all the legit sites can get certificates really easily. So like we're still happy with this trade-off. But yeah, it is a trade-off. Yeah. Mm-hmm.
If I'm like a wise corporation monitoring DNS requests, like what are the actual DNS requests for the Unicode things look like? Are they like exit and dash dash, or are they like in Unicode themselves?
I don't know. Yeah, I wonder how the DNS request is actually sent. I'm not sure. Yeah, I'm not sure. Yeah. Okay. So so let's talk about subdomains. So sites can create subdomains, arbitrarily long subdomains that can be named whatever they want, and those are free to create. So they pay for their domain, but then the subdomains are easy to generate. And in this case here, we're not actually on PayPal. Obviously, this is a subdomain PayPal, which is part of a subdomain called com-webapps blah 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 dot, and we're actually on activeuserid.com, right? So when a normal user visits this who's non-technical, we want to make sure that they know that they're not on paypal.com, even though that's the first part of the URL, right? So have you ever tried to explain to somebody how to tell whether they're on a real site or not? Has anyone ever tried to do that for a relative? Yeah, it's like actually kind of hard. Like you basically say, okay, so it's everything before the first slash. That's the domain, right? You want to tell them basically to find the first slash and then go back like 2 dots, and then that's the site they're on. That's kind of the rule, right? But it's not like, oh, look at everything from the beginning after the first 2 slashes. That's wrong, right? Anyway, so that's kind of, I don't know, that's kind of hard to explain. It's like the most important detail is actually buried in the middle here between like attacker-controlled stuff, and attacker-controlled stuff here. So browsers try to help a little bit. You can, if you ever tried going to a site with a subdomain and just looking at what it looks like. Let's see. So let's go to blah, blah, blah. No, actually, let's go to paypal.com yeah, there we go. I already have it in here. Cool. So if I go to, and now it's not going to load a valid, this is not a valid URL, but the point is, I just want us to look at the URL bar and look at the treatment that the browser gave to it. So it grayed out the path to avoid the user being confused, so that's like slightly grayer. And then Chrome decided to make the whole host name black, including the the fake part over there, the PayPal part. I don't know why that's their decision, but that's sort of what they decided to do. Let's look at other browsers. So what does Firefox do? Firefox tries to help a little bit more. So it grays out the subdomain and just shows you the actual sort of registerable domain, which is actually kind of more useful in this case. This would highlight to the user that they're not on PayPal, right? So that's a better behavior potentially. And then Safari's behavior is similar to Chrome's. It sort of shows you the whole thing. But what I think is interesting is what happens when you shrink your browser down. What actually gets shown? Because sometimes the user can put more numbers in here. And so let's see what happens when we shrink our browser down. Does this look right to you guys? Does that look safe? I can't tell that I'm on example.com right now, right? I'm pretty convinced. I mean, I don't know. That looks like PayPal to me, right? Okay, so that's pretty bad. Let's go back to Firefox and see what they do. So if we shrink our browser down, let me zoom in. So it's gray. So if we remember that the actual host, the actual domain is supposed to be in black, then maybe we'll be saved here. But I think this is also pretty bad. It's letting the attacker sort of get away with a trick here. And then what does Chrome do? So let's shrink this down, and it doesn't look good either. Yeah, so I'm not impressed. I'm not impressed with any of these approaches. But yeah, that's what's happening. Wow. Yeah, and remember, the attacker can literally just put more numbers in here and make this longer. So what can we do? Let's see here. Okay, I'm gonna skip ahead of a few things. So yeah, in that case, I mean, I don't know. I think browsers should do a better job there. But let's talk about this attack. So this is called a picture-in-picture attack. This is actually just a picture of PayPal inside of the attacker's site. Now this is an old browser. This is Internet Explorer. So if you don't recognize the browser UI, that's because this is an old screenshot. But the point is that this actually fools a lot of users. You might think this is like really dumb. How would people fall for this? But this actually fools a lot of users because the attacker controls this UI here, and they can make it, the green bar, and they can make it look however they want, and they can make it look super legit. And so somebody might just think, I have like a window, on top of the other one, and be fooled by this. I don't think there's an easy way to defend against this. Yeah. So there's a paper about this effectiveness of this attack. They said we found that picture-in-picture attacks showing a fake browser window were as effective as the best other phishing technique, the homograph attack. The homograph attack is the one with the Unicode letters. Extended validation did not help users identify either attack. Extended validation is just a thing where you can pay extra money for your certificate, and they'll add extra UI to the browser to make it look fancier, but that doesn't help. Here's another thing. So you used to be able to do this. You can't do this anymore. When you open a pop-up window, do you remember I mentioned those two parameters in the beginning of window.open that are not used anymore? So those used to be able to allow you to configure what features you want to be on the pop-up window. So you could, for example, say, like, I don't want this or that feature. And in particular, you could turn off the location bar. And then you can basically put whatever you want in that pop-up, including your own location bar that's fake. And so that's not a thing you can configure anymore. But yeah, you used to be able to do that. In fact, you even used to be able to turn off the title bar. And yeah, so you can't do this anymore because it's too easy to be used for phishing. Oh, this is a really crazy one. So this is a sort of modern version of this attack. And this works today. So check this out. Watch this video. You're on some dude's blog. And as you scroll down, it looks fine. And then as you scroll up, the browser UI up there is changed to this UI of this URL of a bank. And let's watch it again. Let's refresh and we'll see what happens. So yeah, you're on his blog. And as you scroll down, the browser sort of hides its own UI. And then at some point, he adds his own UI. And then even when you scroll up, the browser's UI doesn't come back because what he's done is there's actually an iframe in here, and you're scrolling the iframe. And so from the browser perspective, you haven't actually scrolled the outer page. And so it's not time for the browser to sort of show its UI yet. And so you've effectively prevented it from showing the true UI. So yeah, really tricky. Really tricky. So again, like some defenses against this are if you're using a password manager, then it's not going to be fooled by any of these attacks because the true domain that you're on is going to be known to the password manager, and it's not going to like reveal your password when you go to log into one of these sites. Now you might be tricked for other reasons because you still see that the UI is misleading, but you won't type your password into the wrong site. Another thing you can do is use a hardware security key. So these are keys which have a secure protocol with the site that you're logging into, and they won't reveal the secret material to the wrong site. Basically, it's similar to what the password manager does. This one's really cool because it also has a lightning connector, so you can use it both on your computer and on your phone with the same key. But yeah, okay, wow, I have a lot of attacks in here. I'm gonna keep going and see what we can get through. So this one's really interesting. This is called cookie jacking. So this was a famous attack in IE in 2011. This one's not possible anymore either, but I'm using all these ones that have been fixed sort of as, again, to give you a taste of like all the things that are possible with all these APIs interacting. So this one is wild. You can iframe the URL to some cookie that you don't own. So in this case, the Google cookie for the user, if you know the URL to it. Now, one problem is you don't know the user's username, so you don't know what folder name to put in here, right? But what you can do is, if you put an image and you make the source be this particular URL, where you put in a server IP, then Windows will think that it's a LAN connection, and it will send the username of the computer just in plain text to that IP address. And so if you're on the same network as this user that you're attacking, in other words, like you're at Stanford or you're in a coffee shop or something, and so you're on the same network as this person, then you just wait for that username to come through, and now you know it, and then now you send them to this page with their username included. And now what's happened is the cookie has been iframed. So literally the text contents of the cookie are in a frame. But because of the same origin policy, we can't go into the frame and read it, right? But it's still kind of disturbing. We see our Google cookie here in this attacker's site. So now how is the attacker going to get the cookie out? Well, if the user somehow were to select the cookie's text and then drag it out of that window and drop it, that's like a paste, basically. They dragged it and dropped it onto the outer page. So how can we trick the user to do this? Well, what if here's a video. So this is what the attacker, this person did. It's really clever. Oh man, don't tell me this is the quality we're gonna have to live with. Okay, there we go. So check this out. So you have the iframe with the cookie, the Google cookie inside it here. And it's just all there, right? And so he's gonna hide the iframe. So this is clickjacking. The iframe is hidden. And then now the user goes to grab the basketball, and they've actually selected their cookie and dropped it into the site. So yeah, you might think this is contrived, but there's other sort of more realistic situations that they show where they They do it with like a more legit thing that you would actually drag and drop. But that's what's actually going on there. Yeah, pretty wild. And there's another one called file jacking. So this one, you basically trigger an upload dialog. So you know when you go to upload a file on a site, and it brings up the little prompt that says, select a file or folder to upload. Well, that UI looks quite a lot like the file download dialog, like asking you where you want to save your file. And so if you just confuse the user enough by showing them a bunch of UI on your site saying like, get all excited about this download that you're about to download, and then they click download, and then this thing pops up, and they pick their downloads folder, and they click OK. Now they've just uploaded, they've sort of given that site access to that whole folder, right? So this is a video of that. So this is like downloading some sort of hacker tools. You're checking all the tools that you want to download. Give me that. I'll only use it for good. OK. And then you click download to, and then this folder that he selected is actually now uploading all his files to the site instead of downloading it. So this is kind of, I don't know, not that surprising when you know what's actually going on. But I don't think the UI in this video is very clear that that was actually an upload, not a download, right? And in this case, yeah, there's all of his like webcam files or whatever. And let's end this video. I don't want to see what's on his webcam. OK. Yeah. So basically, these are attacks. All these attacks are basically attacks on human perception. They're not attacks on like. There's nothing necessarily wrong with the code. In some of them there was, but in a lot of them it's just attacks on human perception. And like one problem in common with all these things is that browsers are sort of allowing untrusted sites to put stuff where users' eyeballs go to look for trusted indicators like the URL bar and stuff like that. So that's the key problem, I think. But so the sort of solution to this, oh gosh, I'm really out of time. We'll have to come back to Google Safe Browsing next time, I think. Yeah, so before we go, I'll just end with, if we assume, sort of like in the XSS example, we assume it's going to happen, right? Like we just assume XSS is going to happen. We have to have some mitigation in place. What we want to do here is think about, let's just assume the user is going to end up on a sketchy site, and what's something we could do? Maybe we could keep a list of sites that we know are bad and just try to like save them from themselves if they end up on a bad URL. And that's the idea of Google Safe Browsing. But we don't want to do this by literally telling Google every time we go to a URL, like, hey, I'm about to visit this URL. Should I go here or not? And like now they have a huge list of everything we visited. So what I'm going to talk about next time is the protocol that Google Safe Browsing uses to allow you to check to see if to see if it's safe to visit a URL without actually sending the full URL to Google and revealing your full browsing history. Cool. Thanks. See you next time.